Hey, thanks so much for coming to my talk about how to stop breaking other people's things. So, I'm Lisa Karlin Curtis, born and bred in London, England. I'm a software engineer at Incident.io, and we work on trying to be the best way to help your team manage incidents across your whole organization, and you should check us out online. And today I'm going to be talking about how to stop breaking other people's things. We're going to start with a sad story. A developer notices that they have an endpoint that has a really high latency compared to what they'd expect. And they find a performance issue in the code, which is basically like an exacerbated N+1 problem. And they deploy a fix. And the latency on the endpoint goes down by half. And the developer stares at the beautiful graph, like posts it in the graph Slack channel. It's got this really lovely cliff shape and feels really good about themselves, and then kind of gets up and moves on with their lives. Somewhere else in the world, another developer gets paged. Their database CPU usage has spiked, and it's really struggling to handle the load. So, what's actually happened here? They start investigating. There's no obvious cause, no recent changes. Request volume is pretty much what they'd expect. They start scaling down queues to relieve the pressure, which solves the immediate issue. And the database kind of seems to have recovered, but they still don't know what's going on. So, then they notice something that's a bit odd. They've suddenly started processing webhooks much more quickly than they used to. So it turns out that our integrator on the right-hand side here had a webhook handler that would receive a webhook from us, and then it would make a request back to find the status of the resource. And this was the endpoint that our first engineer had fixed earlier that day. And just as an aside, I'm going to use the word integrator a lot. And what I mean by that is people who are integrating against the API that you are maintaining. Sometimes that might be inside your company. Sometimes it might be like a customer or some kind of partner potentially. So back to our story. That webhook handler spent most of its time waiting for our response before then going and updating its own database. And what that meant was that our slow endpoint was essentially rate limiting that webhook handler's interaction with its own database. So it would receive a webhook, send us a GET request, hang around while we did whatever it is that we needed to do, get the response, put it into the database, and move on to the next webhook. So it's worth noting that the webhooks in this system are a result of batch processes. And so they're really spiky. They come sort of like all in one go a couple of times a day. And so as the endpoint got faster during those spikes, the webhook handler started to apply more load to the database than normal, to such an extent that an engineer got paged to resolve the service degradation. And the fix here is fairly simple. You scale down the webhook handlers so they process fewer webhooks, and then the database usage returns to normal. Or alternatively, beef up your database. But it shows us just how easy it is to accidentally break someone else's thing, even when you're trying to do the right thing by your integrators and improve the performance of your API. So to set the scene, here are some examples of changes that I've seen break code in the past. Traditional API changes, right? Like adding a mandatory field, removing an endpoint, changing your validation logic. I think we're all kind of comfortable that this stuff can very easily break somebody else's integration. Introducing a rate limit, or maybe changing your rate limiting logic. Docker did this recently, and I think they communicated really well about it, but it obviously impacted a lot of integrators. I'm going to say that a little bit again. Introducing a rate limit or changing your rate limiting logic. Docker did this reasonably recently, and I think they communicated really clearly during that process. But they also had to provide a lot of tooling and extra help to make sure that engineers weren't negatively impacted. And actually, I think that even with all of that, there were still negative impacts from people whose build pipelines were relying on essentially unlimited access to those Docker registries. Changing an error response string. So my previous job was at a direct debit company called GoCardless. And we found a bug where the GoCardless code was not respecting the accept language header on a few of our endpoints. So somebody would send us a request with an accept language header of French, and we would carefully give them an English error response. And so when we found it, we were like, well, this is broken, let's fix it. And so we fixed it. So the error response was now in French. And one of our integrators raised a really urgent ticket with us, saying that we'd broken their software, because it turns out that they were relying on us not translating that particular error because we never had before. And they'd written code that was specifically looking at the error string and applying a regex to that error string in order to make their software behave as expected. Breaking apart a database transaction. This might seem quite obvious in some ways. I think we're all used to the idea that in our own systems, we know that internal consistency is really important. And if we break a database transaction, that we might end up in some inconsistent state that we don't expect. But it's relevant to our integrators too. So as an example, let's say you have a resource that can be either active or inactive. And when it gets deactivated, you create an event to explain why, and you send that event. It would be natural for an integrator to build a UI that explains why this resource was deactivated using the event, so that the user can understand what's happened. Let's say in the past, that event was created inside the database transaction with the state change. And then we want to break apart those transactions because we're maybe breaking apart our monolith and we want our event system to be its own service. There's now a possibility that a resource might be inactive, but there would be no corresponding event. And it's quite likely that the integrator had assumed that this would never happen. And so their UI might just error if you can't find the corresponding event based on that deactivated resource. Sorry, I'm actually going to do that whole section again because that felt very convoluted and like I didn't really explain it very well. So I'm going to go back to just breaking apart a database transaction. The first sentence of that was like, this might seem quite obvious in some ways. Hopefully we can chat after if that's a problem. Breaking apart a database transaction. This might seem quite obvious in some ways. I think when we think about our own systems, we're used to the idea that internal consistency is really important, but it's relevant to our integrators too. As an example, let's say you have a resource that can be either active or inactive. And when it gets deactivated, you insert another row into the events table, which gives you a bit more color about why that user was deactivated. Did we think they were fraudy? Did they ask to be deactivated? That kind of thing. And it would be quite natural for an integrator to build a UI where we sort of say, oh, this user is deactivated and this is why. And in the past, maybe that event was inserted in the same transaction as when we made the user deactivated. And that was all very nice, but we decided we wanted to break that transaction apart. The integrator now has a situation that they've never seen before, where they can get a user and the user says, I'm not active, but they try and get the event and there's no event there because we haven't actually inserted an event explaining why we've deactivated that user. And so potentially our integrator is now going to be rendering an error or paging somebody or throwing an exception because it's encountering a world state that it's never encountered before. And that is a breaking change. Changing the timing of your batch processing. So if you're any kind of payments company, which was my experience at GoCardless, you often have sort of daily batch processes because banks operate in the unit of a day. So GoCardless would have these big daily batch runs that would happen each day to submit instructions to the banks about what to do that day. And we could always see from our logs that certain integrators would create lots of payments just in time for that daily run, which makes perfect sense. They want to wait till the last possible moment so that everything is kind of nice and easy to cancel before the final kind of commitment that is an instruction that they want to issue that day. But because we can see that, we always knew at GoCardless that if we change the timing of those daily payment runs, all of those integrations would break because they were relying on the fact that we didn't send the instructions to the bank until a particular point in the day. And the last one is reducing the latency on an API call, which is the story that we started with. So for the rest of this talk, I'm going to define a breaking change as something where I, as the API developer, do a thing and somebody's integration breaks. And that happens because an assumption that was made by that integrator is no longer correct. When this happens, it's easy to criticize the engineer who made that assumption. But assumptions are inevitable. As a developer, you can't really get anywhere without them. And so expecting people to live in a world of no assumptions is just not very realistic. But also, even if it is their fault, it's often your problem. Maybe if you're Google or AWS, but for most companies, if your integrators are feeling pain, then you'll feel it too, either immediately or in the long term when you're trying to renew contracts. So this view of like, oh, well, they've done a bad thing, so they have to fix it, and it's on them, that just pushing out of any responsibility, I don't think is particularly productive or realistic. There are a few different ways that assumptions develop, and we're going to kind of go through them and then talk about what we might be able to do about that. So some assumptions are explicit, like an integrator asks a question, gets an answer, and then builds the system based on that answer. So the first step when you're building an integration is often to look at the documentation. Although it's worth noting that people often skip to the examples and don't actually read any of the narrative text that you've slaved over. So you really need to make sure that your snippets are super representative of how your system behaves. They might also look at support articles and blog posts, perhaps stuff that you've published or maybe for the third party. And then you have ad hoc communication, which is kind of the most complicated here. What I mean by this is random emails or phone calls, maybe with a pre-sales team or your solutions engineers. It might be a conversation that gets had on a support ticket, or emailing a friend that used to work at the company. And all that ad hoc communication is still driving assumptions that the integrator makes about how your software is going to behave. Then there are other assumptions that are more implicit. So industry standards are quite interesting. You send me a JSON response, you're going to give me an application/JSON content type header. And if I see that content type header, I'm just going to assume that you've given me JSON, and I'm going to probably explode if you haven't. So I don't need to tell my HTTP client that this webhook is going to be JSON. It can work it out for itself. And as an integrator, I'm going to assume that that's not going to change. Similarly, as an integrator, I assume that you will keep my secrets safe. So if you tell me that my access token was used to create something, I'm going to assume that either it was me or there's something wrong with my infra and I've leaked the access token. Generally, this stuff is fine, but in some cases you can find yourself in trouble, particularly if these standards changed. At GoCardless, we had a really bad incident where we upgraded our HA proxy version, which was observing a new industry standard that downcased all of our outgoing HTTP headers. Now, according to the official textbook, HTTP response headers should not be treated as case sensitive, but a couple of key integrators had been relying on the previous behavior and had a significant outage. And that outage was actually exacerbated by the fact that their requests were being processed. They just couldn't process the response that we were giving them. And so that meant we had two systems that were out of sync in a really unfortunate way. And then finally, let's talk about observed behavior. As an integrator, you want the engineers who run the services that you use to be constantly improving them and adding features. But in a way, you also want them to not ever touch them so that you can be sure that its behavior won't change. As soon as a developer sees something, whether that's an undocumented header on an HTTP response, a batch process that happens at a particular time each day, or a particular API latency, they assume it's reliable and they build their systems accordingly. Humans also pattern match incredibly aggressively, not just in software, in all walks of life. For example, it's the foundations on which we build language, and learn languages is all about pattern matching. We find it really easy to convince ourselves that correlation equals causation. And that means, particularly if we can come up with any explanation, however far-fetched, of why A always means B, we're really quick to accept and rely on the fact that A will always mean B. And when you think about it, this is all really quite bizarre. We're all engineers. We're all employed to make changes to our own systems. We should understand that they're constantly in flux. We also all encounter interesting edge cases every day where someone has hit some incredibly unlikely scenario around timing or some combination of fields in your API that causes your code to misbehave. But we all assume that everybody else's stuff will behave perfectly consistently and stay the same forever. It's just a bit strange that we do that, and yet consistently, even as somebody who has written and given this talk, I still make that mistake on a regular basis. None of this stuff is new. A great example of this is MS-DOS. So MS-DOS was released with a bunch of documented interrupts, call hooks, all that retro stuff. But early application developers found that they weren't able to achieve everything that they wanted. And this was made worse because Microsoft would actually use undocumented calls in their own software. So it was impossible to compete using only what was in the documentation. So, like all good engineers, they started decompiling the operating system and writing lists of undocumented information, like Ralph Brown's interrupt list, which was the most famous. And that information was shared, like printed into a book and sold and shared. And these undocumented features became like the cornerstone of all of these applications. And they became so widespread that Microsoft just couldn't change anything without breaking all of these other applications that people used every day. And particularly as an operating system, these applications were a core part of Microsoft's own value proposition. So just breaking them all clearly wasn't an option, no matter whose fault it might have been. We can think of the interrupt list being analogous to somebody writing a blog nowadays called 10 things you didn't know that so-and-so's API could do. And I imagine it might have a similar consequence. Some of these assumptions are also completely unconscious. Once something is stable for a while, we sort of just assume that it's probably fine and it will never break. And we make our resourcing choices based on previous data because napkin maths is always quite haphazard. So when I'm choosing how much CPU to allocate to my pod, I pick a number out of thin air, and then I look at it for a bit and see what happens and change it until it kind of seems happy. And that works fine as long as what the pod is being asked to do is reasonably consistent over time. But as we've discussed, that might not always be true. And we can think about this in the context of that first story, right? The database had plenty of resources until our endpoint got faster. And that was what actually caused the issue for that database and that engineer. So if we want to stop breaking other people's things, we need to help our integrators stop making bad assumptions. The first thing we can do here is document edge cases. Discoverability is really important here as well. So think about the SEO of your site and search inside that site to try and find the information that you're really looking for. And also, don't ever deliberately not document something. If it's subject to change, you should call it out so there's no ambiguity. When it comes to support articles and blog posts, keep your own religiously up-to-date and searchable, and try and be really clear if it's referencing, say, a particular API version or point in time or set of features. And if you've got third-party blogs that are incorrect, try contacting the author or commenting with the fix they need to make that guide work, or perhaps point them at an equivalent page on your own doc site. Because if you get unlucky, that third-party content can become the equivalent of Ralph Brown's interrupt list. When we're talking about ad hoc communication, consistency really is the most important thing, as well as obviously accuracy that what you're telling people is in fact correct. If a developer wants to understand what might break things, they need to know what communication is being out, ideally in a super searchable format. In my experience, many B2B software companies end up emailing random PDFs around or creating shared Slack channels, at which point the engineers working on the product really don't stand the chance of knowing what assumptions might have been made as a result. Industry standards, follow them where you can, and flag really loudly if you can't, or if the industry is not yet settled or is in some kind of transition period. And then there's a lot to think about with observed behaviour. So naming is really important, particularly because, as we discussed, developers don't often read the docs in full, they just look at the examples. So a frequent example is perhaps you have a number that is a number, but that number might begin with a 0, like a company registration number. That's quite common, and often those zeros get truncated and then various bad things happen in the future. And that's because the developer's just seen a number and gone, oh yeah, that's a number, I can just treat that as a number in my code, where actually it is a number, but it's also kind of a string in the case of like a company registration number. You can also try and draw attention to it in the docs, particularly if you have edge cases like that. Just make that your example, and then the developer is much less likely to get it wrong. We can also use our documentation and communication to combat that aggressive pattern matching that we talked about. So if you know that there's something that is true most of the time, but then sometimes isn't, you can call that out explicitly in your docs. Like, we run this batch process at 4 p.m. every day at the moment, but we reserve the right to change it. The earliest that we would ever run it would be 2:30. And that brings us on to that final point there about restricting and documenting your behavior. So I had an issue once where somebody that I was integrating with, they started adding a lot of extra events to every single webhook that they would send us. And our webhook handlers basically ran out of memory because we were only expecting these webhooks that would have like 10 or 15 events. And all of a sudden they had like 250 events. And we were loading in all of this memory, all of this information into this pod that was quite a small pod. It didn't really deserve that. And it would just get killed. It took us a little while to find it. And so I think it's a really good pattern to try and make sure that basically anything that you do with the outside world is restricted and documented both in your docs, but also in your code to make sure that some future change doesn't change that behavior. The first thing to remember is that a change isn't either breaking or not. If an integrator has done something strange enough, almost anything can be breaking. And I think this binary exists because it's been historically used to assign blame. If it's not breaking, then it's the integrator's fault. It's not my fault. You can't blame me. It wasn't a breaking change. But as we discussed earlier, it might not technically be your fault, but it's likely to still be your problem. If your biggest customer's integration breaks, the fact that you didn't break the rules will be little consolation to the poor engineer who's up all night trying to fix it. So instead of thinking about this as like a yes-no question, we need to think about it in terms of probabilities. How likely is it that somebody is relying on this behavior? Not all breaking changes are equal. Yes, some changes are 100% breaking. If I kill an entire endpoint, then a lot of people are going to be really sad. But many are neither 0% nor 100%. Try to empathize with your integrators about what assumptions they might have made. And you can use people inside your organization who maybe have a bit less context about the specifics than you to rub a duck. And if possible, try and actually, talk to your integrators. It's very, very useful. Also, if you can, find ways to dog food your own APIs to find tripwires, either places where your documentation is a bit unclear or places where your API just behaves in a way that you don't expect. And this is particularly good as an onboarding exercise. It really helps new joiners immediately put yourselves into the shoes of your integrators and can help you keep docs and guides up to date, as well as introducing them to the product in a kind of structured way. And sometimes you can even measure it. You might be able to add some observability that will help you look for people relying on specific undocumented behaviors. For example, we might see a spike in a particular kind of request just before our batch process runs. And that kind of helps you identify which integrators you might want to reach out to if you're likely to break their stuff specifically, rather than having to sort of communicate with everybody. For complex products, it's very unlikely that all your integrators would have avoided bad assumptions. So we need to find strategies to also mitigate the impact of our changes. Some of you might be shouting at the screen by now, and I apologize. What about SEM there, or semantic versioning? And don't get me wrong, semantic versioning is super awesome. And provided it's used appropriately, so basically you correctly identify which release type you want, major, minor, or patch, it's a really, really great way to release potentially breaking changes. And we shouldn't just use this for packages, we should also be using this for things like APIs and webhooks. And it solves some of our problems, but not all of them. I can tell you that as someone who's maintained a public API, there are quite a lot of changes that you can't kind of make in this way. An obvious example of this might be the timing of the batch process or reducing the latency on an endpoint. You can't apply every change on an opt-in basis. You kind of end up like sprawling complexity to the point where you end up spinning up one instance of your product for each customer, which carries a whole extra set of challenges that we don't want to go into today. But every new version that you support increases the complexity of your system, and complexity leads to risk. And so there's a trade-off to make here where potentially, having huge numbers of different API versions might also not be the right thing for your product. If a major version doesn't work for your use case, I recommend that you scale your release approach depending on how many integrators you think might have made the bad assumption. We want to have different strategies that we can employ at different levels. If we over-communicate, we get into a boy who cried wolf situation where no one reads anything that you send them, and then their stuff ends up breaking anyway. And surprisingly, the email in their inbox that they didn't read doesn't seem to make them feel any better. You want to start at pull comms. So by that I mean like docs or a change log, which is particularly useful to help integrators recover after they've found an issue. You can then upgrade to push comms, maybe like a newsletter or an email where you're proactively telling people that you're about to do something that might break their integration. This is where it gets really tough. We all ignore emails every day, so try and make sure the content is as relevant as possible. Don't tell integrators about changes to features they don't use, and try to resist the temptation to include any kind of marketing content in that developer-focused comms about, we're making this change and it's going to break your stuff. And then if you're really worried, you can move to what I would call explicitly acknowledged comms. And that works particularly well if you have maybe a small number of key integrators that you want to kind of check in with before pulling the trigger on something. Maybe there's only a small number of people who are using this functionality, or maybe you just have a few really big customers that you want to be really careful about. It's really important to make these kinds of changes often. It's a muscle that you need to practice. Otherwise, you get scared and you forget how, and you also lose the infrastructure to do so. And if you're really unlucky, the cultural incentive becomes to argue that a change isn't really breaking, and you end up releasing things without as much rigor or care as your integrators deserve. We can also mitigate the impact of a breaking change by releasing it in different ways. If at all possible, you want to try and make changes incrementally to help give early warning signs to your integrators before completely blocking a particular code path. For example, apply the new behavior to a percentage of all requests. That will help integrators avoid performance cliffs and could turn a potential outage into a minor service degradation. Many integrators will also have near-miss alerting to help them identify problems before they cause significant damage. If you've got a test or a sandbox environment, that's also a great candidate. Making changes there, particularly if integrators are actively using it, can act as the proverbial canary in the coal mine. And the final point here is about rolling back. If your biggest integrator phones you and tells you that you've broken their integration, it's really nice to have a kill switch in your back pocket to stop the bleeding. Now, that's obviously not always possible because it completely depends on the nature of the change. But it's worth knowing what the kill switches are and also being really clear internally about when that is and isn't possible, so that as soon as that call comes in, you know what your options are and you can communicate really clearly. The only way to truly avoid breaking other people's things is to not change anything at all. And often even that is not possible. And also, as engineers, frankly, we'd mostly be out of a job. So instead, we need to think about managing risk. We've talked about ways of preventing these issues by helping your integrators make good assumptions in the first place, and how important it is to build and maintain a capability to communicate when you are making potentially breaking changes to help mitigate this impact. But you aren't a mind reader, and your integrators are sometimes careless and under pressure and in a rush, just like you. So be cautious. Assume that your integrators didn't read the docs perfectly or at all, and they may have had to cut corners. They may not have the observability of their systems that you might hope or expect. You need to find a balance between caution and product delivery that's right for your organization. For all the modern talk of move fast and break things, it is still painful when stuff breaks, and it can take a lot of time and energy to recover. Building trust with your integrators is critical to the success of a product, but so is delivering features. We may not be able to completely stop breaking other people's things, but we can definitely make it much less likely if we put the effort in and help mitigate the impact if and when it does happen. I really hope you've enjoyed the talk. Thanks so much for listening. Please find me on Twitter @PatRiccartyEng if you'd like to chat about anything that we've covered today, and I hope you have a really great day.